All right, everyone. So welcome back. Welcome back to this channel. So in the last video, we have looked at automatic chain of thought prompting, right? So for in this video, we are going to go through a paper which is written by the smart people at Google, by Google Research Brain Team, Google Brain Team. We have this paper which talks about basically chain of thought prompting. It talks about why chain of thought prompting works and when chain of thought prompting works, and also they have also come up with like some very interesting results, which I think is worth sharing here. Right, it will be helpful for you. Maybe if you like go into the industry, maybe if you're maybe implementing chain of thought prompters or automatic chain of thought prompting, which I've discussed in the last video. Maybe if you want to build something like that, maybe in the future this will be useful because you'll learn some new important techniques, important maybe symbols or signs, or when to use chain of thought prompting and different techniques and why chain of thought prompting works. And yeah, I think we are going to go like understand really what chain of thought prompting is on a very high level, not on a high, on like an overall basis, right? When does it work? For what problems it solves? Right, not only like mathematical problems, but different problems also. We are also going to look about that. Um, so yeah, and like this paper is like 43 pages long, right? It's a very long paper. Can you please excuse me a minute? Yeah, so that is what we are going to cover in this video. We are going to talk about, well, chain of thought prompting, right? Nice. So this is the abstract. um, we explore how generating a chain of thought, the series of intermediate reasoning steps, significantly improves the ability of large language models to perform complex reasoning, right? So again, yeah, so this paper is like 43 pages long. It contains of like a lot of information. So therefore, I have already read it once. So I'll try to cover the most important information, the most important details that I found. And so first of all, I just want to give you an overview of what chain of thought prompting is, right? So if you have watched the last video, you will have a good idea of what it is, but I will cover it anyway, right? So chain of thought prompting. So in chain of thought prompting, so the goal of chain of thought prompting. First of all, I'll talk about the goal, what we will achieve, and after that, I'll tell you how will we achieve. Now, how will we achieve part is actually quite simple, right? Because we don't have to do we don't have to do anything with like engineering of the model. We don't have to do anything with the architecture or anything. All we have to do is like change the prompt, right? So first, I'll talk about the goal. What is the goal of chain of thought prompting? What we will achieve. So basically, when you're solving a problem, so we'll take mathematical problem. Okay, so let's say we have some text problems, right? Some like we'll have some like names, right? So let's say I'll create a problem, right? So something like Joel bought a can of can a ball can or something. I don't know what we'll call that. Each can consists of something like that, right? Each can consists of, let's say, 6 balls, right? And let's say Joel gave 3 cans to his friends, right? Right? Joel bought 6 cans of balls. Each can has 12 balls. He gave 3 cans to his friends, or and then how many balls does he currently have? Something like that, right? So it's quite simple questions, right? And if we could make a model solve these simple questions, we could also make this model that we could scale this up, okay, scale these models a bit and make them make sorry, right? And we could make them make right. So if we could make a model solve small problems, we could also make the models solve larger problems, right? Because these are large language models, right? You could scale them, right? Scaling is definitely not a problem because we could just like maybe train the model maybe more, maybe it's a powerful model or something, maybe have more, maybe fine tune the model. But scaling is not a problem. So as long as we could instill the model to solve problems that are related to this model, as long as we make our language model, as long as we make our LLM solve these type of questions, be capable of solving these type of questions. Excuse me. Right? If you could make a model really find the correct way of solving this problem, we could definitely like scale them to much harder problems. So basically, using in chain of thought probleming in COT, what we basically do is rather than so we want what we want our model to do is we want our model to not solve this problem in just one single step. We do not want our model to solve the problem in one single step, but rather what we want our model to do is to generate some steps, some detailed steps. Right? We want our model to take detailed steps or write down detailed steps to really analyze the question. We want our model to analyze the question and go each step into that question. And also we want our model to generate thoughts while doing the process. We want the model to generate all the thought process that the model will go through in order to solve that problem. By this way, of doing reasoning, right, our model learns to reason, right? Our model earns its ability to reason about different things, and also the model will do better, right? The model will really understand the question rather than mere uh, by hearting or something, rather than mere remembering things, right? Rather than doing some pretty foolish things, right? Just stop that. Will basically make our model reason, right? To use its to reason about the question, to analyze the question in a deeper manner, and produce steps it has to take in order to solve that problem and take that steps in the completion, right? So that is what I want our model, right? So how will we achieve this? How will we achieve this uh, thing? How will we achieve this goal? Well, basically it's pretty simple, right? As I've told you before, the thing is we adjust the prompt, right? While we give the prompt to the model. Let's say we are asking some question like this, some mathematical question or any type of question, in fact, because any question that involves like reasoning, right? Any question that one has to analyze, right? If there is anything, any question or anything or any maybe you are assisting someone, maybe you're shopping, you can use chain of thought prompting. Go about it like step by step of like which category they want, which category they might like. We ask questions before that, and anything with reason, right? Anything that requires reasoning, that requires step by step reasoning, we could use channel programming, not only like mathematical problems. So basically, yeah, so how will we achieve this? We'll have a prompt. So before giving the prompt, we'll do something called few shot prompting. Sorry, few shot prompting. So in few shot learning or few shot prompting, what we'll be doing is while giving the question to our model, just to make sure that the model understands what task it is solving, just to make sure the model has an idea of what task it is solving, and just to make sure that the model knows what it is solving, just to make sure the model has some idea. What we'll be doing is we'll be providing the model with some completions, right? What are completions? Completions are pre-solved questions and answers, right? We're going to have many questions and answers, questions along with their answers. So basically we'll be giving the model with the questions and the answers, and we'll give many of these questions and answers in the prompt of the model, just to make sure the model reads these questions and answers and really understands what is going on, right? When that is, I think, what you might be doing when you are maybe studying for exam, right? If you are studying for an exam, right, before practicing for an exam, right, something, you'll basically look at previous questions, right? You look at previous questions and their answers, and you could really understand what is going on. Similarly, we'll in the prompt we'll give the model with some questions and answers, and in the answers in chain of the prompting, rather than giving the direct answer, in the answer we'll write the step-by-step process that one has to take in order to achieve their answer, right? We'll write the step-by-step process of what it has to be done in order to achieve that, right? So generally, normally, these answers, the questions and these answers, in the answers, these reasoning steps in the answers are wrote by human annotators. Human annotators refers to like humans who write these answers, right? They are generally wrote by human annotators. But in automatic chain of thought prompting, which I have already covered in the last video, or you can go through my channel, go to my channel and search for like automatic chain of thought prompting. I have made a video. in that you don't have to provide the answers. You don't need human annotators to give answers. All you need is questions, and the model will generate answers by itself, chain of thought answers, and basically will have a diversified context or diversified completions. And based on that, the model will learn the prompt, and then answers will be given, right? So that is chain of thought prompting on a very high level. Now let's look at some results, right? Now let's look at some experiments the model that the paper people who wrote this paper have done. We'll look at some experiments, and then we will think about it, right? Introduction, right? The NLP landscape has been revolutionized by language models. Of course, will not be needing that because we already know fully. All of you know that LLMs have been of great use and of great influence to us for us. Yeah. Okay, so this work explores how the reasoning ability of large language models can be unlocked by a simple method motivated by two ideas. Right, first, techniques for arithmetic reasoning can benefit from generating natural language rationales that lead to the final answer. Right, so that is the main thing of chain of thought prompting. Just make sure that natural language rationales or natural language steps processes will be generated by the model, or reasons will be generated by the model, or reasonings will be generated by the model, right? Second, large language models offer exciting prospect of in-context feature learning via prompting, right? You don't have to train the model. Like generally before like LLMs and all that, we have to like train the model from these completions, like update the parameters of the model. But now you don't have to do it. Prompting has become like very powerful, and that's why you could also learn prompting. Maybe I will come up with videos related to prompting also in the future. In this year, we'll do that. So yeah, I mean, so with the power of prompting, we could basically give input output demonstrations, and the model will have reasoning ability, right? That is the main idea of chain of thought prompting. Right. So I think let's move on. So this is chain of thought prompting. We'll just move on because I think don't think like there are many important things. Yeah. So this is pretty important, right? So chain of thought prompting has chain of thought prompting has several attractive properties as an approach for facilitating reasoning in language models, right? So why does chain of thought prompting facilitate reason? That is what we are going to study. So first, chain of thought prompting in principle allows model to decompose multi-step problems into intermediate steps, which means the additional computation can be added to problems that require more reasoning steps. Right. So chain of thought prompting, using chain of thought prompting, we could basically allocate the number of steps, right, rather than having a constant number of steps or constant number of processes that we have to take to receive an answer. So based on the question, the model will decide how many steps or how much computation basically, how much intermediate steps, should be taken to solve the problem, right? Or how many reasoning should be generated. So it will be well determined by the model, right? So second, the chain of thought provides an intermediate window into the behavior of the model, suggesting how it might have arrived at a particular answer and providing opportunities to debug where the reasoning path went wrong, right? So window into behavior of the model, suggesting how it might have arrived at a particular answer and providing opportunities to debug where the reasoning path went wrong. Again, it will provide the model to basically reason through the answer rather than just directly producing an answer, right? Just rather than directly like memorizing or something, rather than directly giving an answer without even thinking about it, we will at least make some reasonings, right? Maybe for future debugging, etc. Right? Um, yeah. So chain of thought prompting can be used for like math problems, common sense reasoning, symbolic manipulation, and it's also potentially applicable to any task that human can solve via language. Right? That's a pretty bold statement, I say. Yeah, I mean it is applicable to almost every reasoning problem, right? Any problem that maybe requires reasoning, right? Finally, chain of thought reasoning can be readily elicited in sufficiently large of the self language model simply by including examples of chain of thought sequences into the exemplars of few short prompting, right? So basically, like, no, doesn't matter how large the model is, we don't have to train the model. We don't have to take the large number of parameters in the model and update them. We could simply make the model uh, generate rationales for answers or questions simply through prompting, which is actually quite nice, right? So right, so these are the properties, and some attractive properties as per the paper, some attractive properties of chain of thought prompting. And then next, they have experimented with arithmetic reasoning, arithmetic, well, mathematical reasoning or something. They have come to here. So they deal with one database which is like GSM 8K, which is a GSM 8K consists of like many mathematical problems, right? Many mathematical word problems, not simply equations and all that, but word problems. They consist of like many high quality, pretty hard word problems, word mathematical problems. That is what they do. India, as you can see, these are all the problems that we have. We have math word problems, free response, which is like no multiple options. I think this is like multiple choice we have, and then we have common sense. Uh, yeah, we have common sense. We have strategic question answers, which is probably, yeah, probably, I know, yeah, yeah, just like questions, common sense questions. Maybe these names do not suggest anything, right? Date understanding, maybe something related to dates and calendars or something. Sports understanding, maybe something related to sports or something. And then we have say can instructing a robot, right? Yeah, so what, let's say we have a problem, or something like clean my table. Recently I just like watched a video in which a human would, maybe I think it is related to say can, human would ask the model to like clean the table, and the robot will like decode all the steps it has to do, and like it will carry out all the steps in a reasonable manner. I think, yeah, that is what secant database is, dataset is. And here we have last letter concatenation, which is symbolic reasoning, right? Symbolic reasoning refers to like uh, some symbolic meanings that we capture, right? They do not be, not definitely have to be like, uh, you know they do not necessarily have to be like reasonable or logical, but just we just do it, right? For example, yeah, we have a name, and like we concatenate the last letters to get some maybe nicknames or something, I don't know. Yeah, something like that. Maybe that's a starting point of symbolical reasoning. I don't know, the paper does that. And we also have coin flip, which is actually state tracking. They say coin flip the coin is a coin heads up. Yeah, something like state tracking, tracking what happens. Maybe one something, some incident, some situation happens, and some situation happens, like what where will we reach or something after like all situations happens. Maybe that is something like that. Yeah, so yeah, these are all the things. These are all the data sets, I think. All the questions and answers, all the type of questions and answers, maybe in which we will test the model. So these are the results. uh these are the, yeah, so there is one thing that they say first. Figure 4, right? In the figure 4, we could see maybe later. Figure 4 shows that chain of thought prompting is an emerging ability of model scale. That is, chain of thought prompting does not positively impart performance for small models, and only yields performance gains when used with models of 100 billion parameters, approximately 100 billion parameters. We qualitatively found that models of smaller scales produced fluent but illogical chain of thought, leading to lower performance than standard prompting. Yeah, that I think this is a very interesting observation, and also quite obvious one if we really think about it. But they found that chain of thought prompting only works for large models, and when they sell as for large models, they mean like 100 billion parameter models, like approximately like 100 billion parameter models, right? Which is like pretty large. So they only like work with 100 billion parameter models, and I mean, maybe the models are not very large because we do have a lot of models, right? We deal with like a lot of large language models, that are close to or even greater than 100 billion parameters. So yeah, if you use chain of thought prompting with smaller models, remember, if you use chain of thought prompting with smaller models, the the text will be like very fluent, but they'll be illogical. And also, using chain of thought prompting for smaller models may also lead to lower performance than standard prompting, right? Rather than providing any examples. So if you do not perform any examples, the model will work better for smaller models than providing chain of thought prompts, right? That is a very important observation. Second, chain of thought prompting has larger performance gains for more complicated problems, right? Yeah, that is, I think, quite obvious, right? Chain of thought prompting, the core use, the core function of chain of thought prompting is to solve problems that are of complex scale, right? Solve complex problems. That is the core use of the of chain of thought prompting, right? So therefore, that is quite obvious, right? So the more complicated the problem, the more increase in performance gains compared to standard prompting. So yeah, that is quite obvious, right? Yeah. And third, chain of thought prompting via GPT-3 and Palm GPT-3 175 billion parameters and Palm 540 billion parameters. Palm is pathway language model made by Google. Compares favorably to prior state of the art, which typically fine tunes a task specific model on labeled trained dataset. Yeah, dataset shows how Palm 50 for uses state of the art prompt to achieve new state of the art on yeah. So basically, what they are saying that is that the current state of the art performance or the current state of the art best model of Palm is overtaken by chain of thought prompting. Yeah, yeah. So basically, we can overtake the current like state of the art performance of Palm using the chain of thought prompt version, right? That is sorry. So that is what that have been said, right? And then so that is one important thing. And yeah, we'll see the results. So these are like different data sets, right? These are different data sets, and as you could see, right, this is yeah, so this is standard prompting. The gray line, the yellow line is like prior supervised best. This is probably, yeah, maybe it is the human level or something, or it is considered best, the yellow line. Yeah, and as you can see, right, lambda is not performing very well. Maybe it is maybe it is a little small or something, right? But you could see here, like, yeah, look at Palm, right? It is chain of thought prompting version is doing way better than standard prompting version, and also with GPT, right? It's doing very good chain of thought prompting versions, and also with like SVMP on SVMP dataset also. Yeah, on SVMP dataset we don't see any difference, any real difference between like chain of thought prompting and the general versions. And here in like MAWPS something, and still not big difference, right? That is also some important things. And now let's get to like why, right? Let's get to why chain of thought prompting works. I mean, as you can clearly see, right? I think, yeah, GSM 8K is like very hard problems, right? But how these models, how the chain of thought prompting is able to help model, right? That is what we should learn. That is what we should like definitely understand, right? So so because like equation only, right? So one reason for why chain of thought prompting might help is that it produces the mathematical equation to be evaluated, right? So basically, if you are solving a mathematical problem, that doesn't necessarily need to be like mathematical problems. You know, you could correspond mathematical equation with uh, maybe a pseudo code or something that has to be done, or some line or some program or something, or something that should be done, right? Definitely could correspond equation with that. But again, mathematical equation I think is a better example. So for example, chain of thought prompting works best for mathematical problems because it will produce the equation that has to be done to solve the problem, right? Given the word problem, the necessary equation or the necessary procedure will be generated by the model. That is and that is what we test. That is what they test. Sorry. So right, and so we test a variation where the model is prompted to output only a mathematical equation before giving the answer. Figure 5 shows that equation only prompting does not help much for GSM 8K, which implies that the semantics of the question in GSM to 8K are too challenging to directly translate into equation without the natural language reasoning steps in chain of thought. Right. So what they're saying is here is that well, GSM 8K datasets has like very hard problems that may maybe in order to solve that problems you need more than maybe simple equations, right? Maybe you need to follow multiple equations, maybe there are many connections, right, or something. So therefore, well, directly we cannot translate the question into an equation. So therefore the model does not work, you know generating direct equations for GSM 8K dataset, right? Direct equations cannot be generated. But yeah, that is what they found, right? So natural language reasoning steps should be done in order to solve GSM 8K problems, right? Uh, so that is why chain of thought prompting works, right? Not necessarily because an equation is generated. Definitely, I mean, equation is generated, but more importantly, natural language reasoning steps. I mean, definitely for high challenging problems, maybe that is what is important. Maybe that helps the model, right, to like have reasoning steps or draw out procedure from the prompt. That is, I think, that helps, I think. And then variable compute only. Another institution is that chain of thought allows the model to spend more computation on harder problems, right? So this is one more reason why chain of thought prompting might work. I've already discussed this. So this, chain of thought prompting might work well because it could determine the number of steps it has to take to solve a specific problem. It could like increase the number of steps it has to take to solve a problem, or decrease the number of steps it has to take for easier problems. It could understand that. Uh, and I think this they also tried that. They also tried experimenting with this. Uh, right. So this variant performs about the same as a baseline, which suggests that variable computation by itself is not the reason for the success of chain of thought prompting, and that appears to be utility from expressing intermediate steps via natural language. So therefore, they have tried it. They have tried using variable compute only. They have experimented to see if variable compute only is the key of chain of thought prompting, but they have figured out that it's not, right. It's not necessarily the main reason for the success of chain of thought prompting. Okay. And then another potential benefit of chain of thought prompting could simply be that such prompts allow the model to better access relevant knowledge acquired during pre-training, right? So one more conception of on why chain of thought prompting works better is that chain of thought prompting helps to activate the model's knowledge during pre-training, right? In the pre-training phase, the model would achieve some knowledge or in inculcate some knowledge. So using chain of thought prompting, maybe you could activate that knowledge, right? So therefore, they test a alternative configuration where the chain of thought prompt is only given after the chain of thought prompt is only given after the answer, isolating whether the model actually depends on the produced chain of thought to give the answer. This variant also performs as same as a baseline, which suggests that sequential reasoning embodied in the chain of thought is useful for reasons beyond just activating knowledge, right? It's not just activating knowledge. Chain of thought not just activates knowledge, but there is more reason, right? That is what they have found through these experiments, right? The experiments that they have done. Right? And then we have common sense reasoning. Right? Although chain of thought is particularly suitable for math word problems. Right? Just as I've said, it's not only suitable for mathematical problems. The language-based nature of chain of thought actually makes it applicable to a broad class of common sense reasoning problems, which involves reasoning about physical and human interactions under the presumption of general background knowledge. Common sense reasoning is a key for interacting with the world and is still beyond the reach of current natural language understanding systems. That is what they have done. That is what they have told. Then prompts, we follow the same experiment setup as the prior section. Okay. Yeah. So they have this, the data sets they use. Okay, we could skip that. Yeah, what they have found is that yeah, so in CSQA, I think CSQA, what is CSQA? Let's see what CSQA is. I'll just go fastly above. Let's see what CSQA is. CSQA, common sense. Okay, so that corresponds to like common sense. Let's look at the results firstly. Yeah, for CSQA, okay, so this is like prior supervised best, and this human. Human is green. The green color is the human one. And as you can see, I mean, yeah, definitely like human is very better, very good at different things, right? So NCSQ in common sense reasoning. So prior supervised best is like the orange line. So there is not much difference. That yeah, there's not much difference between like chain of thought and standard prompting. If you look at strategy QA dataset, chain of thought prompting does very good compared to like standard prompting. And at date also it does pretty good. And if you look at sports, well, it also overtakes humans, which is well quite nice. I don't know what reason that is. So this is like model scale again. So this x-axis is actually model scale. So this is like not like some time or something. Yes, this human scale, model scale. So the largest scale refers to like the number of parameters. The more the number of parameters, the more complex and more and the better the model is. So yeah, we could see that. We could see these results for common sense. And then we have symbolic reasoning. The symbolic reasoning, yeah. So our final experiment evaluation considers symbolic reasoning, which is simple for humans but potentially challenging for language models. Right? Symbolic reasoning is well, yeah, we show that chain of thought prompting not only enables language models to perform symbolic reasoning tasks that are challenging in the standard prompting setting, but also facilitates length generalization to inference time inputs longer than those seen in the few short examples. Okay. So yeah, this symbolic reasoning I think is yeah, I mean there's two things or two tasks, two toy tasks as they say, have been experimented in this paper. So first there is last letter concatenation, which I've already told you. So the last letter will be concatenated to maybe get like a nickname or something, right? Maybe there is something nickname or something. Yeah, just to make sure the model really understands, right? From this data, can the model understand what is going on? And then there is coin flip. So coin flip refers like the current state of the coin. Let's say I flip the coin once, right? I flip the coin once again. Maybe I do not flip the coin, and like what is the current state of the coin? And there is also like and there is also one more thing in which you have like two coins, like shuffle them n number of times in like different directions, and you after like n number of steps you show and you ask like which coin is like in which hand. That is all like state tracking to understand what state is currently here now and how things change. And that's also comes under I think symbolical reasoning. And then that is also refers to here as coin flip. I think when coin flip is checked here or experimented here, and they have found that where is figure eight? That is figure eight, I think. Yeah. So as you can see, yeah, channels are prompting overtakes standard prompting, and also sometimes to a very large extent, pretty large extent. Coin flip also it overtakes the standard prompting. Maybe not here, but yeah, again, this also comes back to the point that the more complexity the problem is, the better difference we could see between chain of thought prompting and standard prompting. That is why if we have four coin flips, then there is more difference, right? And then those are the results. And then I think that's it. I think that's the most important things of the paper. And there is some like huge amounts of references also included in this paper, which we could I think all could skip. There's also like some checklists or something. There are some frequently answered questions. I think this paper is overall very good. I think maybe we'll look at this question. Why increasing model scale improves chain of thought prompting? Uh, you know what? Maybe I will like maybe I'll do like LinkedIn post or something. Right? Maybe I'll read this paper in like more detail. I'll read this paper in more detail and I'll publish. You know, I'll publish or I'll post There are some like very, so yeah. So here there is also like one more very important question: will channel or prompting improve performance for my task of interest? Well, three properties have been told. So I'm sorry for the bad grammar. Yes, so three conditions. If your tasks suit these conditions, then chain of the prompting is good for you. Is will definitely improve your task, right? The first condition is that the task is challenging and requires multi-step reasoning. Again, at this point, stress this paper. So if your task is complex and requires multi-step reasoning, then chain of thought prompting is good for you. It will improve your performance, right? And then number two, a large language model is used, of course. If your task can be solved with directly programming or direct coding or something, or direct models or direct algorithms, and go for them. Don't go for LLMs. I mean, if LLMs are required, then use them. And then the scaling curve is relatively flat. That means, yeah. So so the scaling curve is relatively flat. Maybe scaling refers to like increasing the model size, the number of parameters of model. Right, flat refers to like, okay. So yeah, so make sure that you do not use the model with lower parameters models, and that is what they are saying. And they say the scaling curve is relatively flat. So that's it. That is, so these are three reasons that you should uh, follow, or that your task should adhere to use chain of thought prompting, and be sure that it improves your performance. Right. So I think that's it for this video. Hopefully this video is of any use for you. Again, I'll maybe do like LinkedIn post, or maybe in the future we'll cover chain of thought prompting again, and maybe in the future, and in the future also I'll come up with prompting videos for LMs. I think they'll be pretty useful because they have had like huge amounts of influence on model performance without really doing a lot uh, internally. So I think that's it for this video. Hopefully this video is of use for you, and I'll see you in the next one.